Hey guys, we're back with the notes for 9.1. If you would please go to page 5, copy what you see, and then press play so we can get started. Perfect. We're going to be graphing rational functions. 9.1 is all about using the parent function and transformations. Okay, so let's go ahead and talk about for just a second using this parent function and his table to generate our values that we're going to graph. So if I start by thinking about plugging in a -2, that's like saying 1 over a -2. That gives me a -1/2. I'm going to graph that as going to -2 and then graphing only up halfway. If I plug in a -1, 1 over -1 would give me -1. Okay, so -1 is going to give me -1. Oops, and I actually put that in the wrong spot already, right there. All right, -1. If I graph 1 over -1/2, if you think about 1 divided by halves, how many pieces would you have? That would give you 2. So in this case, I would go to a -2. So again, I'm going only back 1/2 and then down to -2. So I'm halfway left and right, down 2 full boxes, okay? All right, when we think about plugging in 0, 1 over 0, that D and E stands for does not exist. I am not allowed to plug in a 0 there, and that brings me to my first word, asymptote. An asymptote is a line that you cannot cross. So if I'm looking at this one, if my x is not allowed to be 0 because 1 over 0 is undefined, that means I have an asymptote on x equals 0. It's a vertical asymptote. So the way you draw that is you kind of put a blocking dashed line all the way down x equals 0, showing me that you cannot hit that value, okay? All right, let's continue plugging in our next value. If I plug in a +1/2, 1 over 1/2 is going to give me a +2. So I'm going to come over here. I'm going to go right just half a box, but up 2 full boxes. If I plug in a +1, 1 over 1 gives me 1. So over 1, up 1. And finally, if I plug in a plug in a 2, 1 over 2 gives me 1/2. Apologies for the confusion there. So we're going over 2 boxes and up 1/2. After that, we are going to use just those 3 dots as a way to show our direction, okay? When you are graphing these on your own with transformations, I do expect you to have 3 dots on both sides, okay? So 3 on one side of the asymptote, 3 on the other side of the asymptote, okay? Even if there's stretches, try to fit 3. If the third one doesn't fit, then obviously don't put it on there, but most of the time it will. Let's talk about the other option. So as you'll notice, my numbers this way are getting smaller. So 2, 1, 1/2, 1/3, 1/4, 1/5. We would slowly be getting closer to 0. Thinking about going the other way, I'm going -2, -1, -1/2. So same way going this way, I'm getting closer to 0. And that is because I have another asymptote. Down here on the bottom, I'm telling you that y could never equal 0. Think about that. If I'm trying to show you 1 over something equals 0, that's impossible. The only way to get 0 is to have 0 divided by something, right? Well, if I don't have a 0 on the top, I have a 1 on the top, there would be impossible for me to ever make it equal 0. So the way we're going to show that is with another asymptote. We are going to show that we have a horizontal block right here at y equals 0 also. Now, when you do transformations, obviously if your graph is moving to the right or to the left, your x value is going to change for your asymptote. Obviously, if you're moving up or down with your transformation, your asymptote is going to move up or down. So y equals 2 if it goes up, y equals -2 if it goes down. If you're moving left and right, it might move to x equals 2 or x equals -2, depending on which way you're going and how far. But now that I have all my values, let's go ahead and show you what this graph looks like. He should be approaching the asymptotes in both directions, but not touching them, okay? Same thing this way. He's staying below the asymptotes and on the left of the asymptote. It is not going to cross over that blue line, so try really hard to make sure they don't touch, okay? All right, let's talk about the transformations real quick. You guys have used these transformations before. Remember that the x in here, let me make that a little smaller, sorry. The x, whoever's in here with the x in the bottom of the fraction, that's moving us left and right. Those are my liars. Remember, if you see x plus 2, you're actually going left. And if you see x minus 2, you're actually going to the right. That number would have to be in the denominator. Now, if you have a number adding or subtracting and it's past the fraction, that's a vertical shift. It would have to be off the fraction, and those ones would tell you the truth. So plus would move it up, the whole graph, including the asymptote, or down if it was a minus. Finally, only compressions, stretches, or reflections that we're going to deal with are coming off of A. So quick reminder here, we would be stretching that vertically, so we're changing the y. We're going up or down that much more. Also remember, if A is negative, that's a reflection over the x-axis. Instead of my graph looking like this, it would switch to be in these quadrants. Okay, so just as a quick reminder, if A comes out negative, that's what you're looking for. All right, last piece, if you will come down here, pause the screen for just a moment and copy what you see. Perfect. We talked about as x gets bigger and bigger and bigger, we were saying 1/3, 1/4, 1/5. This is going all the way to 100, 1 over 100, 1 over 1,000, 1 over 10,000. As I move this way, fraction or decimal, my numbers are getting smaller, but they are not ever going negative, okay? So as my x gets larger and it goes on to positive infinity, my f of x is getting closer and closer to 0. Same thing as I look negative. As my x's get more and more negative, so negative 100, negative 1,000, negative 10,000, they are getting smaller, but they're getting smaller in the negative values, okay? So they are approaching the exact same thing. They are approaching 0. So this is what's called end behavior. And it will be shown all of the time through this unit. Okay, it's super important to know that the main asymptotes for horizontal dictate your end behavior. Okay, so when we ask where is it approaching, or you're following a trend of one of those dashed lines, that tells you as the x fades off to the right and as x fades off to the left, where are they getting closer to? Okay, all right, if you missed anything on this screen, I'll zoom out for just a moment. You could pause it, copy it, but we are done.